for checking the health of the system. Anything goes wrong, anything goes wrong on the node part, immediately kubelet will be knowing that and passing that information over through the kube proxy to the master node, and through the kube API server, the kube API server, it will go to the relevant components. First of all, it will go to the etcd to fetch to validate, cross validate the data. Okay, and then it will go to the scheduler. Scheduler will take the help of controller manager. If the replication has gone wrong, so one more replicator, the replicator controller manager will be called, and all those things will be in a very synchronized manner. So we will start from the next slide. Okay, so basically we are interested to know about the Kubernetes components that we were talking about. Okay, so here we have, as we said, this is the cloud. Okay, so if your Kubernetes infrastructure, the services are also lying over the cloud with you have gone for a SaaS type of cloud services. So if it is over the AWS cloud, we are saying about EKS. So the kube controller manager, sorry, this will be kube controller manager, but it is more particularly cloud controller manager, which interacts with the cloud. There is the controller manager, there is the API server, that is the etcd, that is the kube scheduler. These are the four important components. This is an additional one if you have implemented Elastic Kubernetes Services over the cloud, which is a SaaS platform for Kubernetes over the cloud, AWS cloud. Assuming that is fine, that is whether it is there or not, all these four controllers or the four components will work in tandem along with kubelet and kube proxy over the nodes. So if this is node 1, node 2, node 3, there can be hundreds of nodes. But everywhere the configuration will remain the same. And everywhere every node has to connect. So this node 1 has to connect to the API server or the cluster, and that is called joining. So we say we are adding one more node into the cluster. So we say we are joining one node, and the connection is, this is the node and this is the master. So the connection is always like this. So when you connect, when you join, it is always one unidirectional from the node right to left. Assuming on the left is the server or the master node. Okay, it is never you cannot say a master will need to join the node. No, this is not the thing. Okay, so there can be all 100 and there is one command, one kubectl command through which you will join the cluster maintained by and managed by the master. So it is always a join. This is a join. There's a very interesting command to how to get it. And once you get a hang of the cluster and what is inside it, you know very well the kubeadm way of installing. So there are two ways of installing your cluster, Kubernetes cluster. One is through kubeadm. Better to write in capitals. kubeadm. Or basically you say kube administrator, or another one is through implementing of EKS or AKS or your GKE over the Google Cloud. So Kubernetes services over the AWS Cloud, Azure, or Google will be another part of sort of an installation. This is another type of installation. But if you are very well, you know how to do it from your own hands, from the scratch, okay, you are a master, you become a master, you actually have a good hands-on. And in our course, we always go for this sort of an installation because this is very simple. This is you do not have any credit because everything will be taken care by AWS or Azure or Google. So you just have to graphically do the things. Everything will be taken care. But this is the main thing. If you master this one, you know in and out of how you have configured your cluster. Then it becomes very easy for further nodes to be taken inside and getting into the cluster. Or you can take out one node from, you can deinstall or dejoin, or you can retag back the um, the node. If you don't want, you want to sunset this node from this cluster, you can do it as well because you have done the entire cluster with your own hands. So once you have done, your node is ready with the components. The master node is ready with the components. What are the components? HCD, API server, the main component, scheduler, controller manager. Everywhere you need to install Docker or Mesos or Rocket. Okay. Anyway, the thing is, sorry, 1S. It will be 1S. So this is nothing but a CRI. You have to install a CRI. Okay. This is on the master part. And on the slave node or on the worker node, better to say worker node. On the worker node, you have to install kubelet, you have to install kubeproxy. Of course, can anybody tell me whether there will be a kubeproxy on the master node? Whether there when you install, will there be a kubeproxy on the master node as well?
No.
Yes, you have. But you do not need to install it separately. Okay, whenever you will establish a connection between the slave and the master, a queue proxy will already would be there on the master node as well. Because see, these are again pods. This is a pod. So and the application of queue proxy is within one pod, one or two pods. HCD is a pod. API server is a pod. So that means the entire application is within the container. Each of them is a pod, not the Docker. This is a pod. This is a pod. Okay. This is a pod. This is a pod. Now, whenever you will establish a connection over between the nodes, that is a cluster connection, there you need to have a pod network, pod networking. So between this, there is a uniform pod network that you create or that you install. Pod networking. When you do this, you will find that a queue proxy will be automatically installed onto the master node as a pod. So the worker node and the master node will communicate over the networking component called queue proxy. Is that fine? So that can be an interview question. Whether you only have queue proxies on the node, on the worker nodes, or you also have at least one pod of queue proxy installed on the master node. Your answer will be yes. Okay. Will you need to have Docker on both? Do you need to have Docker on both the nodes, master and the slave node? Your answer is also yes. Okay.
Yes.
Any question? Any question? So these are all done through some commands. Basically, you will execute the commands or through the kubectl. Now you can ask whether and how this particular thing comes. It will only be the kubectl is a component as well. That is the interface between the CLI. The Kubernetes CLI is through which you can issue commands from outside to the Kubernetes network. Is, see, all the commands will first flow into where? That you are the person, you are a user or an actor. Okay, you can be a DevOps guy, you can be a Kubernetes Kubernetes administrator, you can be a database administrator, you can be anyone, you can be a developer, or you can be a Kubernetes developer. Okay, anyone. Whenever you are issuing some commands over the, just give me 1 minute. Hello, আমি একটু সেশনে আছি রে। Okay, so what is happening is whenever you issue any command, okay, from the external user through the utility tool, this is a tool that will be installed whenever you are installing the cluster. Okay, that is automatically done. You don't have to separately install this. It comes within the bundle package anyway. So where will this command go and get interpreted or processed? Will it go to the node? See, you cannot write a single command for the node through the kubectl. First of all, kubectl will not help you write anything over there. So nothing interacts, nobody can interact with the node directly other than the master node. Everything has to come to the master node. But where? Which component? It will go first. Anyone?
HCD.
API server.
API server, not HCD. HCD, scheduler, controller manager, kubelet, kubeproxy only works under the instructions of API server. So this command, first of all, will enter the cluster through the API server and get interpreted and get worked. So this is one of the interview question. So it will be the API server who will process any kubectl commands from outside. Or basically, not only any, see, this is your browser. Okay, you are going to access one pod having some Java application, and that is within the Kubernetes cluster in some of the pods. So remember, if there are three pods, the three nodes, so this pod will have its presence either, let's say there are three replicas. So can you tell me the distribution of these three replicas of the same application, Java application? Over, say, let's this cluster is having one master node and three slave nodes or worker nodes joined to the master. So they are working in the cluster. So the cluster is active with one master node and three worker node. Now there is a Java application replicated. There are three replicas of, or maybe five replicas. Let's say five. So many users are accessing this particular Java application. So there can be 5 or 50 or 500, but these are replicas. Replica means the same application is available as replica. Now, how will you say that 5 is distributed? Is there any logic? Who is going to distribute or establish the pods over into the nodes? Whenever there is a manifest file called deployment, this is an instruction file. So it is, you say, uh, some script that you have written, Kubernetes script that is in the deployment file, and through which you are asking API server. This script will be, this deployment manifest file is residing where? Is it in the nodes or is it on the master node? When you create this is a manifest file. This is a Kubernetes, you know, you can say Kubernetes objects. These are objects. Deployment, secret file, config file. These are all objects of Kubernetes. Now tell me, if this is where does it get created? On the master node or on the slave nodes? Remember, all the Kubernetes objects are created whenever on the master node. Yes, always. Not a single object of Kubernetes can be created on the slave nodes. The slave nodes are very, very important. Sometimes you have the slave node configuration bigger than your master node. Can anybody tell me why? Why it is necessary to have your slave nodes configured better or than the master node?
The master node serves
Because
as a copy in case the other slave nodes go down.
No, I'm saying why the master node configuration. Let's say this configuration is something like 64 GB internal memory RAM, uh, say 1 terabyte of hard disk storage or storage, and maybe say 16 processors, CPUs. Okay, but here I have better than the configuration of a master node on each of the slave nodes. Can anybody tell? Instead of 64 GB, I have 128 GB RAM on the node. Maybe uh, 15 or 16 terabyte of storage and 32 processors.
because
But
the slave nodes actually run the workload, so they have to be bigger.
yes, because this master node does not, so no traffic is diverted over here. No traffic. Yeah, there will be a load balancer. Okay, and the load balancer will take the instructions from the API server and whatever, but the traffic will be directed to the nodes because your application resides over here. Hundreds and hundreds of application over here, over distributed over the slave nodes. So naturally, your entire load will be on the nodes, not on the server. Server is good. You have to have a good enough thing because you have to manage so many nodes. Okay, but that's fine. But your application resides over the worker nodes. So let's say if I have 5 replica of a particular Java application which the users are going to access from outside, yes, definitely the thing will be driven through API server. But anyway, I will finally end up. Can you tell me what would be the thumb rule of distribution of these 5 replicas over the 3 nodes? And who does it? Who has that logic? Who has that, you know, the task of uh, creating those pods and distributing those pods over the available cluster nodes? Which which part of the master node or which component of the master node will have that function?
Scheduler.
Very good. The scheduler, not the API server, not the HCD, not the controller manager. The entire thing is the logic is built within the scheduler to understand why and how the pods, the replicas of the pods will be distributed, because there can be many applications. One is Java application, one is C++ application, one is Python applications, all distributed over the slave nodes and orchestrated within the Kubernetes architecture, orchestration. So the now how do you think that 5 will be distributed logically and judiciously? Will the scheduler schedule all the 5 replicas over onto one node? Is it logical?
No.
No, never. Because if the node goes down, all the 5 pods goes down. So there is nothing to fall back upon. So somebody who is using the Java application gets stuck. Nothing working. So logically, I cannot distribute, or the scheduler will never distribute all the 5 replicas in one node and divert all the traffic into one node. No. So this can be distributed as 2, 2, 1 or maybe 3, 2. This is entirely maybe at that point of time when it was creating and distributing those nodes, maybe this was overloaded or quite it has a load percentage of 65% occupancy, whereas this was around 50% and this was around 45%. At that point of when the load was, the pods were getting created and distributed. So scheduler will try to avoid this because it is, and the threshold that you have assigned for each of the nodes, where after which the node can be tainted. The term is tainted automatically. So this is the threshold you have designed or you have configured. Just give me 1 minute. And you have already reached 65%. So there is only 10% beyond which this will be labeled as this node will be labeled as tainted once it has reached 75%. So at that point, when it has reached the 75%, the label is tainted and no further traffic, whatever the traffic is assigned or allocated or directed over here is fine. It will not redirect any further load onto this, neither any pods will be created or distributed over here. So what is remaining in the cluster? These two nodes. So it will distribute maybe 3 pods over here, over into this node, and 2 pods over here. Okay, that is the part of the scheduler. Now I have to move to the next slide. So we have seen that your master node is having these components as API server, scheduler, controller manager, etc. over a Linux platform, that is the operating system, and this is the master node. And here on the component node, on the worker node, the components are, what is that? Kubelet, container runtime interface, CRI. It can be from Docker. It can be from Mesos. The product is not important. The platform is important. So Mesos and Rocket. But you will find Docker everywhere. Okay. So the container runtime engine or interface has to be there, as well as kubeproxy. Kubelet, kubeproxy, controller manager, etcd, API server, scheduler. I'm repeating again and again because those things should be almost always on your lips when anybody asks anything on Kubernetes. So the node can be hosted over Windows, Mac as well. Nowadays, Mac can also be a part of the cluster. Okay, so Mac and of course Linux. This is the most popular choice. This is the next choice, and Mac can be another choice. Where? But since, see, Linux servers are high profile servers, high configuration servers. So better, because as just now we have discussed, your nodes have to be very powerful and your nodes have to be available 24/7 into 365 days as like your server, because your applications are mission critical applications. They need to be available 24/7. So therefore, most of the organizations will have the nodes configured over Linux. You can leave it as it is. Linux will never go down. But for Windows, after say 48 hours of running continuously, you may need to shut it down, or the window itself can hang. Similarly is the case with Mac. Okay, so on the master node components, we have etcd. It is a highly available distributed key. We have also already discussed about etcd. I'm just going through it very fast. So the distributed key value store. You have the key for the reference and you have the value. So it's a memory, sort of a memory and the memory address. You go and refer to the address to get the data within that address. So key value store, it's sort of a database which is used to store cluster-wide secrets. You are going to store cluster-wide secrets. All the important information over the spread over the cluster are all stored over etcd. It is only accessible by the Kubernetes API server. Nobody else can access it other than the API server, as it has sensitive information. You can never access from outside directly. You cannot have any commands where you can extract anything from etcd, however good you are, but there are no commands that is available to you. So you have to come through API server to go to get the information from etcd. Okay. So distributed database, which is etcd, is the most important component of the master node. All the configuration changes that we are making, all the deployments being created, all the scaling operations being performed, all the details of those are stored in the etcd database. Very, very important. The desired state is stored in the distributed database etcd. It is recommended to have 3 to 5 replicas of this. Now, this is a very important information. See, generally, we have one API server pod, one scheduler pod, one controller manager pod, but you must always go for, by default, it is one etcd pod, but for safety, for security, for stability, for reliability, for availability, you must go for more than one replica of it, because it's a pod. So you need to understand that this is a pod, fine. This is also a pod, one will do. This is also a pod. But what about this? I can manage but with a big risk. If there is only one pod of etcd, we must have a replica, at least one. So if this goes down, at least the entire cluster will fall back on this, and immediately see API server knows that that this thing has gone down. So it will ask the scheduler to schedule the same pod again. So at any point of time, if you have created two replicas of etcd, two replicas will always be at your service. That is the beauty, and that is the mechanism. So but but if you had only one etcd and that goes down, then the entire API server cannot recover it so fast. Okay, at that moment, even if it is for few seconds, while it is trying to rebuild the replica, okay, it can go down. The entire cluster can go down for few seconds, and there can be a huge impact. So therefore, it is you need to have at least 3 to 5 replica sets of this etcd in the cluster so that the information on the desired state is not lost. This is an interview question. Will you go for only one replica of etcd into the master node? You say no. They will ask why. Then you say no, that this is the reason. All Kubernetes cluster configuration details, secret keys, passphrase, passwords, etc. are stored in etcd and can only be accessible by API server. So all secret informations are stored over here. One cannot access etcd directly. It is designed in this manner to make the configuration highly available and not allowed to be tampered easily. Now coming to the API server. API server exposes, Kubernetes API. So all the APIs, the functions, the application programming interface is exposed through API server. Kubernetes API is the front end for all the Kubernetes control plane, and it is used to deploy and execute all operations in the Kubernetes. So just this is the main component of Kubernetes master node, without which no API calls can originate. etcd cannot call another function. Scheduler cannot call another function, or it cannot call controller manager without the being driven by API server. Everything is driven through API server because the API calls are originated from API server. So if the scheduler wants to call controller manager, it will fall back on API server to allow it to use one of its services, one of its API calls. Okay, that is the mechanism. That is the security. This is the endpoint for Kubernetes services, because endpoint, why? Every external users, external entities will have this as the endpoint. All will be redirected to the API server from outside. That's why it is called the endpoint for Kubernetes services, which gets exposed for controlling the various API services provided by master node to slave nodes, pods control, deployment, etcd component APIs, all pods information, etcd information access, all the pods IPs are registered to this endpoint. In fact, everything, whatever you can think of Kubernetes cluster is all over here. The second most important component inside the master node is the API server. If anyone does any changes through CLI, Google Cloud console, or if there are changes done through the Google Cloud GUI workloads onto the cluster or through kubectl, then all these changes are registered with the API server and then processed. You can use a graphical interface to access your Kubernetes cluster, or you can use kubectl commands to access the API. You are making an API call to the cluster through kubectl CLI commands, or maybe you are using the Google Cloud Console interface to access this.
Sir.
Yeah.
Sir, what is the first important component, sir, in ETDC? I mean, it's
No, HCD
okay.
cannot work in everything on its own. It has to depend on API server. So the most important component will be the API server. Yeah, I'm
Okay.
not saying that scheduler is not important, controller manager is not important, HCD is not important. They are also important, but API server, without an API server, if somehow the API server does not function correctly, because why we need two data stores, or at least two replicas minimum, two or three replica HCD, because of the data it holds.
Hmm.
So that the data must be in sync. So anytime API server should be able to access. So if I have only one HCD pod, then it can go down if the because pods are very temporary in nature. Okay, they can go down if the network is not available, if the pod network is not working, so it can go down. So many reasons are there for a pod to go down. Uh, so in that case, API server is undone. That way, HCD is one of the important components, but the most important thing without which the master control cannot work, the control plane does not work, is the API server. Is that fine?
Yeah, got it, sir.
Okay. So the next is scheduler. The scheduler takes care of the scheduling of all the processes and the dynamic resource management. So resource management, like you are creating a pod, so you are allocating resources, you are executing a deployment manifest file. So who finally gets the acts together is the scheduler. API, I mean that deployment manifest is just an object. Somebody has to execute the objects according to the instructions given in that script. And who does it is the scheduler. And then therefore the dynamic resource management, that's why you design your deployment accordingly, according to the resources that you want to allocate for the pod, and everything will be described or given into that script called deployment script or deployment manifest file, which is an object of Kubernetes and manages present and future events of the cluster. Event scheduling is done within the deployment and through the scheduler. Okay. It is basically saying about all the configurations that it does dynamically over onto the nodes for the pods. Kube scheduler component schedules the pods to the nodes in the cluster based on the consideration of the several health metrics of the nodes. As I was saying, that it will already find out what is the health condition of that node, whether it is overloaded or it has reached the threshold or it is going to reach the threshold. So, and whether the node is tainted already. All these considerations are done before it can schedule a pod with the resource allocation. For example, how much CPU, RAM available or storage left? Are there any port conflicts? All this will be considered by the scheduler. It knows how to do it and find out, and then accordingly take a decision to create the pod with the amount of resources available. Last is the controller manager. So the controller manager runs all the controllers on the Kubernetes cluster. As I told you, you get inside the cluster and get outside the cluster, out from the cluster through what? Through the controller manager. Although each controller is a separate process, to reduce complexity, all controllers are compiled into a single process. They are as follows. So everything is compiled and known to one controller manager. So controller manager is the boss or the program manager or the project manager. So this is the project manager or the program manager. And from it, there is the node node controller. That is also one code, one component of Kubernetes component that will be called by the controller manager if you want to do something on the node. Okay, if the scheduler wants to configure something on the node, it will call the controller manager and controller manager will call the node controller. Similarly, a scheduler finds that I have to replicate 3 replicas of a particular pod. Okay, 3. So what will it do? It will call the controller manager. Controller manager will call what? The replication controller. Replication controller. And another thing is somebody from outside wants to access one one endpoint over some worker node. Endpoint means some application which is residing on a particular pod or in a node. So it will API server will take that instruction to get that service. It will go to the scheduler. It will give it to the scheduler. Scheduler will give it to the controller manager. Controller manager will call the endpoint controller. Endpoint controller. So the endpoint controller in conjunction with the kube proxy will try to go, and with the help of kubelet, all the things will work together and it will go to the particular pod in the node, which is the endpoint. Service account, token controllers, all these are part sub managers of the project manager. So this project manager is dealing with all these functional leads, functional heads called node controller, replication controller, endpoint controller, account, service accounts, and token controller. Service accounts are secured accounts within the cluster. It can only be accessed through the service accounts controller of the controller manager. Token controllers, for all these are auth, the auth security, all token. So one is JWT. JWT is Java Web Token. This is for the security measures, security level access. Because you have to be, you have to secure your application. So whoever will be authorized through this JWT, I'm just giving an example. There are lots of other tokens. So everything will be governed through or validated through the token controllers of controller manager. Only then you will reach the endpoint through the endpoint controller and you will access the service after you are authorized. Is that clear? How secure it is? So we have discussed about controller manager. Okay, let us go to the next slide. So kubelet components. What are the components of the node? The first is kubelet. Kubelet takes the specifications from the API server and ensures that the application, see, the kubelet is talking to the API server for all the details that because the API server will have the access to the deployment manifest file, the object, and therefore it knows the specifications of the pod. Kubelet will access those specifications through the API server and ensure that the application is running according to the specifications which were mentioned in the deployment. So where is this mentioned? Anybody? Where is the configuration of the pod mentioned?
Manifest files.
Yes, manifest files, which is one of them is the deployment. So there are scripts which are which have after you execute them through some kubectl commands, you will create the pods with the specifications of how much CPU, how much memory, how much storage. All these things will be all defined, and whether they are replication. I mean, how many replicas will be there? Whether 3 or 5 or only one. Or by default, it is only one. But when you say 3, that means 3 replicas of the same application will be created. So all this will be mentioned over here. Who will execute that? API server will execute through other components, and kubelet will know this specifics or the specifications of this pod through the API server. So each node has its own kubelet service because you have to have installed the kubelet for each of the node. So you cannot have a shared kubelet between the nodes. No, each kubelet will function only for that node, specific to that node. So the node agent kubelet is the component on the worker node. It monitors the activities in the worker node and communicates the health of the node to the master node and more specifically to the controller manager. Followed what is mentioned. Kubelet is the agent, node agent is the component on the worker node. Always, it is not available on the worker node, on the master node. It monitors the activities in the worker node and communicates the health of the node as well as the pod. So I should have written over here, not only the health of the node, it should communicate the health of the pods. Health of the node and pod and pods to the master node and more specifically to the controller manager. Because everything will come through the controller manager, then it will go to the API server and fine. Now coming to the kube proxy. This proxy service, proxy means somebody is always available to help the function or the job, the running of the system goes on without any hindrance. So this proxy service runs on each node and helps in making services available to the external host. So whatever services that you are requiring from externally, okay, it will come through the kube proxy, go to the kubelet and find out, and the kubelet will take the help of API server to find out that particular service that it is required. Service means some application service, some application that the user is trying to access. It helps in connection forwarding to the correct resources. So what is the correct resource? What do you mean by the correct resources? What is the correct resources in this case? Nothing but
Controller manager.
I'm sorry. It helps to connect the connection forwarding to the correct resources. So the services that are required, that means it will go to the endpoints, which are the nothing but the pods, the applications, the particular application that the user is trying to access. It is available through the kube. It will go to the correct resource, whichever endpoint it is getting the endpoints. Whenever you fire a query over the browser, it is through the URL, and the URL will have the endpoint of that application that you are trying to access. And remember, there are thousands of pods running in the system. How will you reach into a particular pod which having your particular service is the whole story about how it goes. It's a huge mesh of services. You cannot believe how many services are running, but you want to access a particular service, then you have to discover the service in a particular way. That is called service discovery. And this starts with kubeproxy. Kubeproxy enables port forwarding of the services to the external nodes or master. Whenever, whenever we are deploying new pods, remember, it is coming from the deployment manifest file. You are deploying new pods or services, we need to forward the port to communicate to other pods or services so that these services are discoverable to the external master nodes. The external entities can be part of the cluster or outside the cluster. Kubeproxy is nothing but the networking component. Deployments created and exposed as a service is possible for the kubeproxy, is possible due. It helps in exposing the services around the nodes and the pods. So basically, it will take you to that particular service that you are looking for. So container runtime, there is a question. Container runtime is needed to run containers inside the pods. See, a pod is there. I will come to that section. So the pod is the external layer of a container. This is a container. And there is the application, which is an image of the application inside the container. And the image is running because the container is running. And on top of it, there is one more layer, abstraction layer created. This is the pod. The whole thing is a pod. This is the container. You know the container because you have learned Docker, and this is the image inside the container. So the image is embedded within the container and the container is embedded within the pod. Why a pod is necessary is we will come to that. So container runtime is needed to run containers inside the pod. So for that, I need a CRI to run this particular pod. Basically, I'm trying to run this container, but there is a layer. So I will have to use this layer to go inside the container to run, to make it up and running and maintain that it is running. Docker is the most popular container runtime engine inside Kubernetes worker nodes. In fact, Kubernetes can use any OCI, Open Container Interface runtime, like it can use Mesos or Rocket. Any, or if there is anything else. The Docker does not come as a default container engine. It can be any other container manager other than the Docker. This is for our understanding process to understand containerization is general. Containerization general in with Docker. Whenever we say container, we refer to Docker, but it is like whenever you ask for a paste in a shop. So Colgate is so popular. You say, I please give me Colgate. You say, I want a paste. No, you say, please give me a Colgate. It has become so synonymous. So container engine is nothing but always we mean a Docker engine. So what happens if the master node gets down on the API or the API server component crashes? Will the applications running within the pod stop running? Can anyone answer this question? See, the question is in front of you. Will the applications running within the pods stop running because the master node has gone down?
No, it'll keep running.
It will keep running. Yes, correct. It will keep running. No, as the worker nodes and the pods continue to run, though no changes to the node pod configuration can take place unless master node is made up and running. But it will run as long as your pods and node is up and running. Once one pod goes down, since the master node is not running, API server cannot make the replica up and running. So that way it cannot run after some time. Are you getting me? So if you are making it run for long without the master node, it may happen that, let's say there were 3 pods, replicas of a pod. I mean the same application, Java application, same application running as 3 replicas. Everyone is getting accessed by the external users. Now your master server is down. Okay, API server is down. And after some time, so they are keeping running. No problem, no problem, because they are working on the nodes. The node is not down, no, only the master node is down. So after some time, maybe after 5 minutes, maybe this pod is down. Will the application stop running? And will this pod be replaced by immediately by the other pod? I mean, the another replica of that pod will be created? No, because the API is down. API server is down. So it will, after 5 minutes onwards, only these 2 pods remain with that application. But the application does not stop running because your automatically whoever was accessing this pod will be directed to any of one of these pods because they are the same application. Now, after another 10 minutes, this pod goes down. How many pods remain? The traffic does not get impacted because the traffic is still diverted to the remaining healthy pod automatically by the Kubernetes architecture system. After some time, after another 15 minutes, 20 minutes, this pod also goes down. So now what happens? The application crashes. Now it is, you can say, the application stops running. No user is able to access it because you have no services which can correct or make the replicas up and running again or replace the replicas. Is that clear?
Yes, sir.
If all the pods are running, if nothing is happening, then it will keep on running without the help of the master node. Okay, so the pod is the smallest unit of Kubernetes. It is an abstraction layer over the container. Now, it is not in my scope within these 2 hours to let you know how a pod is created. In our hands-on sessions or in our course, job-ready courses, we explain in details or we do hands-on on how we can create a pod over the container, create a layer over the container. Usually the thumb rule is you must not have more than one application per pod. So it is only one application in one container, that is one image in one container. Therefore, one pod will usually be one application. Each pod, whenever you create a pod, it will get its own unique IP address because you have to communicate between the pods. So these are the 2 pods. These are the 2 pods. Okay, pod number 1, database pod, and the application, and pod number 2. Let's say this is a Java application. This is a MySQL database server. MySQL. They will communicate. The Java application will exchange the data, store the data, delete the data, read the data from this pod because they can communicate over the IP. So this pod is created with an IP. So these 2 pods will communicate with each other. This is a container and this is the pod on the top layer. Okay. So because a container cannot have an IP address of its own, so you create a pod because the pod can have a IP address, IP port. So these two pods are communicating over the IP. Now, as you know that this pod can go down or this pod can go down. So will you find this IP anymore? A new pod will be generated because there is a replication. A new pod will be generated by the scheduler based on the API server and whatever the specification in the deployment file. So a new pod will be created, but replacing this pod. But will this IP be replicated? IP cannot be replicated. A new IP will come into the picture. So what happens every time you have to, this is a new IP. So the earlier communication between this IP knows this IP, but now a new IP is generated. So again, you have to re-establish the connection between these two IP, between these two pods through the new IP connection has to be made. Yeah, it will be done automatically, but there is some latency. And if you are manually maintaining the network on your own as an administrator, then you have to take care of this connection, reconnect. You have to do some reconnection between this. So this phenomena keeps on happening. And for these two, it is fine. But think of there are thousands of pods, and anytime any pod can go down, and you have to re-establish the connection. Is it not cumbersome? Very difficult. And it can be a nightmare if you are going to maintain the pod network with the IP. So we come to see the new IP address on recreation. On recreation of a new pod, a new IP address will be created. So every time you will have to redo the connection. Whereas, so to overcome this hurdle, we have gone for service. So service is another manifest file. So like the deployment file, you create a manifest file like deployment. For creating the pods, you create the pod with the specification and the pod with the IP address, but you attach a service. So you write a service manifest file, which is YAML, but these are all YAML files. So it is very easy to code. Just you need to know the syntax. That's all. And you write the service. So you attach this service with the label of the pod. The pods will be labeled. Okay, you attach a service to this pod. Every deployment will be associated with a service file. So your deployment, you can have 5 replicas of this particular pod. That's fine. But each of this pod will be associated to this service. And service can never go down. Even if the pod gets down, the service will never go down. So therefore, the IP address is within this service. So this IP address does not change. You associate the pod, which is replaced by the replica, and you get the same service. Are you getting me? The advantage of why you create a service attached to the container. See, now the communication is between service to service. This will never die, or the IP address internal to the this is called internal IP. Okay, this will never be the never change. This will never change, never. Even if the app goes down or the pod goes down, because it is service based communication. This is very important, very important. 5-star. Somebody understands the service well is understanding Kubernetes very well. Everything is on the service. I do not have a scope to explain in details on this, but you remember a pod now, a deployment is associated, or a pod is associated with a service which never dies. So you know the internal IP address of the service, and that's all. And service can be labeled. Service can be labeled. So you go by the service name to connect to the pod. So externally, you just access the label of the service. You do not need to know the IP address. So this label of this service will take you to the particular pod or replicas of pod which is associated to this service. So if you can access this service, you are ending up, this is the endpoint of that application. Are you getting me? Any question? So you just have to know the service that you want, and that service will lead you to that particular application or the pod, because this service is associated to this pod. So there is a particular slide on how replica sets work. It is very, I mean, it is through the selector and the label. So every pod will be with a label, a selector, and you use a selector within where? This selector, this label comes where? Okay, this will all come in the deployment manifest file. Earlier, we used to use replica set instead of deployment, but deployment is much more versatile because you have a blue-green deployment. It is only possible when you use deployment manifest file to configure your pods. And there you can label. So you have defined a pod with a label within the deployment file, and then in the service file, in the service manifest file, you will access this label. That means you have associated this service to that particular pod, because that pod is having that label. So can you understand the link? So you are defining the selector within the to identify the pods, and the selector will have a label. So this is how you do the replication, and you find out the pods relevant to that particular label and the service. So why we use deployment and not replica set? Replica set is prior to Kubernetes version 19. With Kubernetes, right now we have Kubernetes version 30. Version 30. So 19, from 19 to 30, we have deployments. Deployment manifest file. Between 1 to 19, 18, from one version, Kubernetes version 1 to 18, you had replica set. This is an object of Kubernetes. Deployment is an object, like service is an object of Kubernetes manifest file. Similarly, replica set was a manifest file. But prior to 19, version 19, 1 to 18, you have replica set. So this is not very flexible. We never use it now after 19. So a deployment is a high-level concept that manages replica sets and provides declarative updates to pods along declarative updates. This is very important, that you could not have done in replica sets. So the pods become dynamic in nature. It is not static. It can change its requirements depending on the demand. So because that is possible because you have used a deployment manifest file to create the pods. along with a lot of other features. Therefore, it is generally recommended to use deployments instead of directly using replica sets. You use deployments. Replica set ensures that a specific number of pod replicas are running at any given time. However, a replica set doesn't support a clean rolling update. Rolling update is the main part of blue-green or canary deployment. Small chunks of deployments. So blue-green deployment, canary deployment depends on rolling updates, and that is possible only with deployments manifest file. A higher level concept that manages replica sets and provides declarative updates to pods. It handles updates in a controlled way, providing mechanisms for updates strategies like rolling updates, paused updates, rollback to the previous version. So everything that you need, rolling update, that means your update is step by step, gradual, rolling updates. Paused update, you can pause an update at this stage before you go to the next stage. You can pause, check, test everything, then go to the next stage. So that is all possible because you are using deployment manifest file. And of course, the rollback, you go from here back to here where you started because something has gone wrong. This deployment doesn't work. You wanted to version upgrade from 10 to version 11, but version 10 is working fine. While trying to do version 11, there was some problem while you tested, and then you simply tried to roll back what it was earlier. That is possible again with the sort of applications that are deployed using deployment manifest file. So you see, I have just shown you the deployment application in Kubernetes. So you as a developer, you are using the Kubernetes. So it is deployment using the scaling, updates, and rollbacks within the deployment manifest file. You create a pod which is embedding the container and the container embedding the application. So a layer of pod has been added because of this deployment over the container. So you mention the specification of the container, specification of the application, specification of the pod in the manifest file called deployment. Deployment in Kubernetes is a controller which helps your applications reach the desired state. The desired state is defined inside the deployment file. So where it is mentioned? It is mentioned in the deployment manifest file. Manifest file. So deployment is an abstraction layer on top of pod to achieve the desired state of the application. The desired state is in terms of replicas, health checks, resources. So everything you can define within the deployment manifest file. Deployments play a crucial role in managing the applications. Managing application deployments in Kubernetes. They provide a declarative approach to defining and managing the life cycles of applications, making it easier to scale, update, rollback, and you achieve automation, automatic scaling. It is only possible because you have used dynamic deployment of the pod. Abstract, because you have gone for an abstraction, you must be having some concept of object-oriented programming. Abstraction is one of the concepts of object-oriented programming. Anyway, abstract away the underlying complexities and provide a higher level. So you are hidden from the underlying complexity of the application, of the implementation. Okay, you only concentrate on what you want, not how it is done. Deployments ensure the desired state of the application and automatically handle scaling, rolling, updates, and rollbacks automatically. As I told you, the service, there is the external service and the internal service. External service we will learn about Ingress in a moment. So it is sort of a, you want to connect uh, to the app from external sources like a browser, where you are giving the service endpoint, okay, and with the along with the port. But this is not a very practical and secure. Hence, we introduce another component called Ingress, because when you are introducing the service port and the app service IP, this is you are exposing the world. The hackers will can easily hit your application and can do a havoc. So you must hide your calling in a certain way, and therefore you must go through some ingress with a secure protocol and domain like, so you are mentioning only the domain. The rest, the internal implementation of that will be taken care by the ingress. Ingress is, I will come to that slide. So the request goes first to the ingress, which forwards it to the external service. Now, you cannot bypass ingress if you have implemented ingress. It is like a layer, which it is like a gate. Before you enter the castle, you will be confronted with a gate. You have to give your identification and everything, and you have to know where you want to go. Okay. All these things, when validated through Ingress, will allow you to access the external service. Now, similarly, in the internal service, the database application should not be connected to the external resources. You cannot, because database is holding your very, very important data is everything. If you allow external sources to gain access to your database from outside, can you think of the mess that you are creating, the security hazards that you are creating for your application? You cannot allow that thing to happen. No database access is allowed from external point of view. It has to come through the application layer, and you can access the application only through the ingress or externally. So we'll come to that. So services are used to load balance the traffic. So if you are accessing a service, whether it's an internal service or an external service, either you are coming through Ingress or internal service of Kubernetes, then you can be able to go to the replicas or the pods. Services are used to load balance the traffic among the pods. It allows round robin distribution among the healthy pods. So service is such a versatile thing. That is, you have created a service for your pod, attaching it to the pods, like you have created the service manifest file for this pod. These are from the deployments. This is from the deployment. This pod was created from the deployment. And the similar pods were created because these are replica 1, replica 2, replica 3. They are the same pods, same application. And this service was attached. Service was created by the service manifest file. So this was attached to this deployment through the label of the pods. And so what happens is now this service is attached. So if you can externally access this service, which is the internal service, you reach the pod. This is available through pod labeling. The labeling will be done by the deployment and the service will access that label. So that means you are attaching this service to the deployment. Is that point clear? So you can approach getting this access from external service as an external service or internal source. So this is internal service. And if you give an ingress layer an ingress layer, which is also a load balancer, sort of a load balancer. This service is also a load balancer. It can understand where to distribute the load. Ingress is also an inbuilt load balancer. So in this case, it will not go to the internal service. It cannot, because it is coming from outside. It will go to the Ingress. Ingress will take you, if your call to this Ingress is valid, it will take you, Ingress will take you to the service, internal service, and internal service will take you the pods. Can you understand the flow? Can you understand the flow now? So you are externally accessing, you cannot access directly the internal service. You have to come from outside. So you have to access, you cannot directly go to the pods directly, So there is an ingress layer. This you are accessing through the external nodes, that is called node port. So this is the external access through the node port. Node port will direct you to the, because this node port is aligned or configured for this ingress. So this node port will take you to the ingress. Ingress will, if there is a validation of your call, it will know that you are a valid user and your endpoint is a valid endpoint. So it will then go and call this particular internal service, and the internal service will in turn take you to the pod. So can you see the various security layers that you have implemented? Any question?
No, sir.
Great. So coming to the last topic of the day, and that is the concluding part of this entire DevOps journey, is to understand the ingress. Ingress controller. Maybe I will take this out. So Ingress, as you know, in an AWS Cloud, okay, when you try to access your server from outside, okay, through the cloud. So this server is the EC2. You say something, some traffic coming in is called ingress. So you configure what? The security group with the ingress rules. And then the traffic coming outside from the EC2 server going back here. Let me go back to this. This is a bit, yeah. Going back, coming back, or coming outside the EC2 is called egress, right? Ingress is in, egress is out. Inbound, outbound. Inbound, outbound. So ingress, so you are coming, ingress refers to the act of entering. You come in to the Kubernetes cluster, and then you get the output as egress. Okay. Now, this is the simple way of understanding. Now, thing is, an ingress is an object, Kubernetes object, K8S object, that allows access to your Kubernetes service from outside the Kubernetes cluster. You are outside this cluster. This is the cluster. Cluster means there is the master node, there is the worker nodes, all within the cluster, not outside the cluster. Okay, you need to access some pods distributed within the nodes. Now to do that, you will come through outside external agency, external from outside of the Kubernetes cluster. And then you have to access the ingress, which is an object that allows access to your Kubernetes service. So there will be a layer available before you enter the cluster. So you can say this is a load balancer, as well as it has logic and rules. There are rules, ingress rules, that will validate your endpoint where you want to go. Then it will call the ingress if the validation rules are validated. If the rules are validated, you are following that rule. One of the rules is to take to a particular service which is available in that cluster, and you call an internal service through the service. And that internal service will take you to the pods associated for that service. You can configure access by creating a collection of rules that define which inbound connections reach which services. So the rule of reaching this particular pod will differ from the rule of reaching another pod. So you reach this worker node for this particular pod through some rules. This will vary with another worker node with another pod. And all this collection of all the rules that will allow your traffic to go to access your application within this cluster is defined within the ingress object. So ingress works on YAML. It is like you can declare what you want or how your rules will look like inside the ingress object. You define the backend rules. Each backend rule defines a service. So let's say your application URL, you are trying to access an image application. Those are distributed over some nodes as image pod 1, image pod 2, image pod 3. So you will hit this rule to go and take you to this internal service. This is the internal service. Okay. And that internal service will take you to this image. If you wanted to access the videos, you will not hit the image. Your URL should hit it will define so that it will ask for this particular video, and that rule must be defined within the backend rules of that ingress. That will take you to the video service and its port. So ingress is a cost effective. Now, why cost effective? If you are going for a AWS load balancer, it will cost you AWS load balancer. It will cost you hugely, quite good, or which enterprise level organizations can afford. But you are working in a small to medium sized organization, and maybe the organization has hired you with a big amount of money because you know how to configure it with very less price. So you go for Ingress, implementing Ingress controller. Ingress is a combination of Ingress API object and Ingress controller. So Ingress is a cost-effective replacement of load balancer to access each of the services from outside is called Ingress. Through configuration of rules to access or route the inbound connection to the required service. Okay. Kubernetes Ingress is an API object that helps developers expose their applications and manage external access by providing HTTPS routing rules to the service. So within the Ingress controller, we will configure an Ingress object. We will create Ingress object with the rules defined. You can say Ingress is also a manifest file that you can define to create an object called Ingress with all the rules within the cluster. The rules are defined to go to the routing to that particular service that you want within the cluster. It can simplify production environments because it facilitates a simple method of establishing rules to route the traffic rather than creating specialized load balancer or manually exposing each service with a node. No, I do not want to spend so much money on load balancers, or I have difficulty in configuring each service within a node. There can be mistakes. So why don't you just simply implement the rules, the routing rules, how to route to that particular service? That's all. Once you reach this service, the cluster IP service, once you reach this cluster IP service, you see cluster IP. This is the internal service, internal service. If you cannot access the pods without having access to the service. But how do you access this internal service? Is through Ingress. Now let me write this. So Ingress consists of Ingress API object and Ingress controller. So you are the person. You are trying to access a Java application which is available in these 3 replicas of the pods. Okay. Your target is to hit this. Your target is to hit this. If you can hit this, you are easily going to access these pods. If you cannot hit this, you cannot reach any which way you try. So what happens is, first you will be directed to go to the Ingress service. That is the Ingress API object. Through the node port, basically we will not use the load balancer because we don't want to spend much money on this. We will simply use external node port. What is node port? I cannot explain it over in this session. It's a very important concept. Any external sources will access the node port, not the internal cluster IP. So this is the external service. External service is node port. And this is the internal service. So external service node port, through the node port, you are in the URL, you will specify the node port. So your application name, let's say some cancer hospital. Let's say I'm just saying that this is an application, colon, and then the node port. Node port will be between 30,000 to something. So it will be, say, 31010. 31,000. Yeah. Let's say this is. So here you go by this, or you can give a domain name. A domain name, let's say Kalkey training.com. This is the domain we have purchased from GoDaddy or from Google. Okay, and thereafter actually this is embedded. So this is hidden. This node port is hidden within the domain. So you access the domain, and the domain will take you to the Ingress service, which is the Ingress object. where the rules are defined, and that rule will take you to the Ingress controller. Ingress controller will validate the Ingress rules. And the rule, one of the rule is to take you to, let's say, demo.com/video. This is the rule defined within the Ingress object. Okay, and that because it matches with one of the routes, so it will route to this cluster IP, which is the internal service, and then it will, of course, go to this application. Now, another one, you wanted to access the images, not the videos. So what will you have a rule within the Ingress rule is demo.com/image, and that rule matches with the rule which is defined within the Ingress service. Therefore, it will take you to not this, but this. And this is going to take you, this is going to take you this pods, which are nothing but images. More or less, did you get it?
Yes, sir.
So there is the way to implement this. Just the last slide, diagrammatic representation of Ingress. So you are the user and you are using some domain name, something.example.com. These are the DNS registrars. In this world, there are organizations which will give you access to, you give like you are creating some business of your own. So you need to have your business name unique. There cannot be two Amazon company, one in India and one is US. No, it will not allow. The global trade will not allow you to have a duplicate name of a business, established business. So everyone can have a Adidas. You are a shoe manufacturers and your shoes are coming out as Adidas with the name of Adidas. Will it be allowed? No, because Adidas is a renowned company. They have their copyright of that particular business name. You cannot use it. You will be arrested. Your business will be croaked. So there are organizations who will give your access, your domain name, some unique domain name. It can be GoDaddy, it can be Google Cloud DNS, or if you are going for AWS, then there is a famous service from AWS called Route 53, which will assign you with a DNS name. So they will register your thing like with basically this is an IP address. But how they have given you? So this is the CNAME. Actually, your application name is example.com. So it will be appearing as star. One of the CNAME is star and the other one is star.apps and www. So actually it will be like this. Your domain name will, when you fire a URL, you are looking for www.apps.example.com. Whenever you are saying apps.example.com, you are actually, because it is this is a DNS record, so you are actually going to hit a particular load balancer. Okay, if you are using cloud load balancer, you are going to hit that cloud load balancer because it is this internal IP address that you are addressing to, because it is embedded within this domain name. This is called domain name. You have been assigned a DNS name, your company domain name. So it will hit a cloud load balancer. Okay. This will lead you to a particular endpoint, and because you have configured an ingress controller Ingress, Nginx. So Nginx is one of the famous Ingress controller. Nginx is also a reverse proxy server, proxy web server. I think you have heard the name Nginx. Nginx is one of the pods, is a pod within the Ingress controller. Ingress controller is this thing. So whatever this will be created whenever you install the Ingress controller, it will be in the Ingress Nginx namespace. So namespace is a very important concept in Kubernetes also. So your application will be in a particular namespace. Your system pods will be all, the master node pods will all be in a particular namespace called Kubernetes namespace, kubedns. Okay. Anyway, I'm not going to that details, but let's say you have created a Ingress controller with a service endpoint. So the external load balancer, or you can directly hit this Kubernetes, that Ingress controller. Ingress controller will match. So these are the Nginx pods within the Ingress controller. It can be one, it can be multiple. That's why it is called Nginx Ingress controller. Ingress Nginx controller. And this now, because this is a sort of a load balancer, it will take you to your whatever the services that you require, because it matches with the rules that is defined. So you see the rules. This is the Ingress rules under ingress.yaml. So you will create this object manifest file and do this API example.co, whatever the host, and this is the path /payment, and the backend is payment service, and /auth, then it will go and hit the auth service. So this is the, whenever you hit the internal payment service, you see this is a internal service. This is an external service. Okay, the internal service will take you to the payment service. This internal auth service endpoint will take you to the auth service. That means this is an application, separate application, auth application, authentication application. This is a payment application. But anyhow, if your rule does not match with whatever has been configured for this particular cluster, you will never reach your endpoint. So Nginx config maps, TLS secret, service account, all these are, secret files that can hide your implementation of all these details. So these are Nginx config maps. Config maps is a security file. TLS secrets, service account. So all these are hidden. You do not need to worry about this. These are already, when you install Ingress controller, this will all manifest files will be coming into picture. So this is all about Kubernetes. I have tried my best to impart a bit of a knowledge. It is a vast, like an ocean. So it cannot end over 2 sessions of 2 hours. It needs a lot of hands-on practice and everything. So I will end the session today. If you have any questions, please let me know. I will stop the recording, but I am available to take your questions. So Shubhro, if you are there, can you please also stop the live streaming? Anyway, so I have tried my best over the last so many, almost like 2 months, more than 2 months, 3 months almost, because I have taken 12 sessions, more than 12 sessions. Okay, over 12 weekends, and sometimes in between I was absent for some work and some family issues. Anyway, that way it has been more than, I think, 3 months.
Thank
Yeah,
you
more
so
than
much for valuable session, sir.
yeah. Thank you, Shravani.
And it's like all your efforts, like we make proud of you, sir, by getting a job.
Thank you. Thanks for a lot these kind words. It gives me a lot of motivation.
Thank you,
So
sir.
that's the reason. You are the reasons which motivates us, people like us, to keep on with this activity.
Hmm. And nowhere we can find this much of informative, like in other free sessions.
Huh. You will have PPTs, but it is
Yeah.
on the very surface, on the upper
Yes.
surface. You will not
Like
go into that much of.
foundation. Yeah. You're giving lots of foundation.
Yes.
Thank you
Though
so much, sir,
it
for
is
that.
still very less, I will
Yeah.
say, but enough, good enough to start
Hmm.
having an interest to learn deeper and deeper and deeper. In fact, that is the motivation. That is the objective of this internship sessions.
Hmm.
Certificates doesn't matter. You see,
Hmm.
you produce your certificates. You are an AWS certified engineer, or you are a cloud or architect. All these are fine to get you the interview. But when you face an interview, if you cannot answer the questions, if your foundation is not good, what will the certificates do? They will never take you.
Hmm.
I never give importance to certificates. Certificates are good when you have got a job, then for getter promotions or switch over to the bigger projects. These certificates, or you want to change your function or your domain, then certificates. You started with as a Java developer, then uh, you wanted to go to a cloud architect. So then you go for a AWS cloud certificate, administrator certificate. Then you become an architect because you are switching over from one domain to the other domain. Then someday you wanted to go into data science. Okay, you have a very good foundation of DevOps, you have very good foundation of cloud and Linux and other things, and then now you wanted to upgrade your skills into some other domain that you have not tried earlier. So then the certificate will matter if for a data science or AI, some certificate that you take. But otherwise, to get a job, your certificate won't matter. At least in US jobs, certificates
Hmm.
don't matter at all. They will ask, and if they get your answers, whether you have certificates or not, they will absorb you. I think that foundation is what I tried to build. After a few weeks gap, again, I think if my director permits me, we will continue this effort.
So what is the motivation like for this session, sir?
For me,
Yes, sir.
motivation is like, first of all, I have no uh, monetary gain. First of all, it is very important. That is, in fact, that my director has relied on me to continue this internship sessions for so long is really a motivation for me,
Hmm.
that there is a trust on
Yeah.
on me. And because there are, besides these sessions, I have I used to take almost 43 batches we have taken. I have taken in the last 43 DevOps batches over the last 3 years, 3.5 years. Okay. And many US students have benefited from these trainings. I mean, most of us has immensely got so much of praise and some kind words, so many things. So that journey has started long back. Right now, I am involved into some very innovative projects in our company. So therefore, these sessions have dried out. I mean, for the last 6 months, I am not taking any DevOps courses. But I think we will again revive it. Cybersecurity AI, data science, and DevOps. These are the three streams we do the job ready trainings.
I really appreciate your patience, time, and effort, sir. We will learn those soft skills also from you, like patience, commitment.
Yeah, that is either there or not there. That
Yeah.
cannot, that you cannot learn. That will come automatically.
Yes,
Once you
yes.
love your job, love your uh, knowledge, if you want to gain true knowledge, then automatically these things will come. You will get
Mm.
a lot of patience because when you start diving deep into any particular subject, you will have to have patience. Otherwise, you cannot go. You will
Mm.
always think of uh, somehow closing this chapter and getting a job, getting an interview.
Mm.
That way, that is, of course, that is the compulsion. You cannot avoid. You cannot say, I will keep on learning for the entire life. Okay. Once you get into a job, I think many people just get complacent and they do not upgrade their skills. That is the danger thing because
Mm.
the things are changing so fast, and especially with the AI and the technology coming thick and fast. So it will be very difficult for, say, think of the COBOL developers, C++ developers, where they are. They, if they stuck to their own that skill only, they would have they had been already obsolete. So it has to be whether it is Hadoop or the databases or big data or data science. We have to keep on upgrading with the new trend, at least to be aware of the technology. If not gaining the expertise, you have to be aware and you have to adopt the skills very fast.
Okay, sir.
Okay, then. So let us end the discussion. It's 23. I
Yeah,
mean, it
11
is
o'clock.
11 o'clock in India.
Yes, sir.
Yeah. All right, so thank you so much.
Yes, yes. We will meet again. I will keep posting messages over the group.
Yeah, okay, sir.
Okay.
Thank you, sir.
Thank you. Thank you. Thank you,
All right, thank
everyone.
you. All right.
Yeah.